Hello, welcome back. Welcome back to the beginning of second semester. We are going to start with talking about our atmosphere. That's what chapter 15 is all about. Chapter 15.1's title is just the atmosphere. By the time you get done with this part, you should be able to describe the importance of the atmosphere to our planet and its life. You should be able to outline the role of the atmosphere in the water cycle. You should be able to list the major components of the atmosphere and know their function. And you should be able to describe how atmospheric pressure changes with altitude. By the way, I know my voice sounds weird. I know that you can't see me this time. I am out waiting to be tested for COVID. So I'm not at the school. And okay, let's just say I don't look my best right now. So I'm just going to go ahead and do this verbally. You'll be able to see the screen. It's all good. We already know, or hopefully you know, that Earth is surrounded by a thin layer of gases and particles that we call the atmosphere. It is because of this atmosphere that liquid water is able to form on our planet. Without the atmosphere, the water particles would kind of drift out into space, and Earth would end up being like the moon. It would be cold, it would be lifeless, because the atmosphere is what helps hold that heat, and the water and some of the other greenhouse gases and other gases in our atmosphere helps hold all that in place. It also helps block a lot of the radiation from the sun, and it's because of blocking that radiation that life was able to form on our planet. That and the fact that we have water. Two really important atmospheric gases are carbon dioxide and oxygen. By now, you should know about photosynthesis and that cycle. Plants, we all know, need carbon dioxide. Animals need oxygen. Carbon dioxide, CO2, oxygen, O2. Plants create oxygen through photosynthesis, and animals create carbon dioxide through respiration, which kind of is a neat cycle that has to happen for living things to exist on our planet. In photosynthesis, the plant takes 6 carbon dioxide molecules from the air around it. It takes in 6 molecules of water, and it takes in sunlight. It then goes through photosynthesis and creates C6H12O6, that's sugar, and oxygen. It's 1 molecule of sugar and 6 molecules of oxygen. The plant uses some of that sugar for its own life processes. So it uses some of that sugar to make flowers, and some of that sugar to make the leaves and things like that. These sugars and oxygen are exactly what we need in order to survive. So animals, including us, including, yes, little bunny rabbits and cows and everything that eats plants, all herbivores, take in or eat the plants. In respiration, we take in those sugars and that oxygen, combine it together, and we release 6 carbon dioxide molecules and 6 water molecules. And then energy, because this is how we get our energy, is by cellular respiration. Photosynthesis and respiration are basically the opposite of each other, and they need each other in order to continue. We need that cycle of photosynthesis from the plants, provide the oxygen and everything that we need, and we provide the carbon dioxide and everything that the plants need. We need that cycle to continue. In the hydraulic cycle, or the hydrologic cycle, or the water cycle, we know that liquid water evaporates into water vapor. This water vapor spends a lot of its time in the atmosphere, and it's a lot of the cause of weather on our planet. The water is evaporated from the lakes and the streams and the sidewalks and the streets after it rains, and hangs out basically in our atmosphere as water vapor. Weather is what the atmosphere is like at a particular time and place, and it changes frequently. So when we're talking about the weather, we would say it's 76 degrees outside now. Tomorrow it's going to be 32. It's supposed to snow in the next week. Those are all weather. It's what's happening in the atmosphere currently, or in the recent past, or in the recent future. Weather will change. Climate is the long-term average of the weather in a particular place. Okay, climate is, you can't say that climate is 76 degrees right now. Climate will never be a right now thing. It is always the long-term average. So an example in your flex book that I really liked was the weather today in Tucson, Arizona might be snowy. Maybe it's snowing in Tucson today. But the climate in Tucson, what is Tucson, Arizona known for? It is known to be warm. It is known to be dry. So that is the climate. Okay? If you have questions about that, please be sure to email me. Ozone. Ozone is a molecule. It's O3. So it is a molecule where 3 oxygen atoms are combined together. Ozone is really important in Earth because it absorbs ultraviolet radiation in the upper part of the atmosphere. Higher level life like us would not be able to survive. Basically, any animals that didn't live deep down in the ocean would not be able to survive, because the ultraviolet radiation from the sun would basically cook us. It would kill us all. It would kill everything. So ozone is important to Earth. That's why you keep hearing a lot about the ozone layer is being depleted. There's not enough ozone. We're getting holes in the ozone layer, that kind of thing. Because if that happens, then too much ultraviolet radiation will be able to hit our planet and be able to hit us, and life as we know it would not be able to exist. The atmosphere and our oceans are what helped keep temperatures in the range needed for life to exist. If we didn't have the atmosphere, Earth would be too cold at night because all of the gases would just be evaporated, and it would be too hot during the day. Sorry, I need to change that. Where that says too cold, I'll need to change that. Hopefully it'll say too hot when you see it. but it would be too hot during the day because there would be nothing to block all of that ultraviolet radiation, and it would get really, really, really hot. Greenhouse gases such as carbon dioxide, methane, water vapor, and ozone are what trap the heat in the atmosphere. We're going to talk more about those greenhouse gases later in the chapter, but it's what helps keep the right amount of heat here. It doesn't let all the heat out into the atmosphere or into space, but at the same time, it doesn't make it too hot here on our planet because it blocks a lot of the sun's heat from hitting us. Gases are made of matter, so they take up space, they have mass, they can transmit energy. Remember, that is the definition of matter. If they take up space and have mass, then that's matter. Their ability to transmit energy is really important because without the atmosphere, Earth would be more like space. Space doesn't have gases in it that can transmit energy. Sound waves have to have matter to travel through. So since space doesn't have any matter, then it is silent in space, and Earth would be like that if we didn't have our atmosphere and those gases in the atmosphere. Maybe by now you remember from a science class somewhere that nitrogen makes up 70% of our air. Everybody goes, well, wait, we need oxygen. We're supposed to have oxygen. Well, if we get 100% oxygen, that can hurt us too if you get too much of it. So nitrogen makes up 78% of our air. Oxygen that we need to survive is only 21%. And there are other gases that make up the other 1%. Some of those gases include carbon dioxide, which we've already talked about, water, which we've already talked about, argon, and yes, even krypton. If we had too much oxygen, it can hurt your body because your body isn't made to have that much oxygen. Yes, when you go to the hospital and you are on oxygen, it's usually 100% oxygen, but that's why they usually put you as a mask or those little tubes that go up your nose so that when you inhale, you are also getting regular air mixed with that oxygen. Humidity means the how much water vapor is in the air, or it's the mean atmospheric water vapor. As you can see, the western U.S. is much less humid than the eastern U.S., except for the coastal areas, which kind of makes sense because there's humidity, there's water vapor coming in off the ocean from both sides. So that's going to give us a little more moisture. But if you look, Arizona is right there next to Mexico in the orange and the yellow areas are New Mexico and Arizona. California is also very, very dry. Nevada is very, very dry. If you look up Nevada, you would see that there is a big desert in Nevada, so kind of tells you that it's really dry. Humid air usually feels heavy. It feels sticky. Dry air is more comfortable. Remember in the summer, in those days in the summer when it's going to rain pretty soon because it's just sticky and the air feels kind of moist in the air. And then it rains, and a day or so after it rains, it feels more comfortable because the water has come out of the atmosphere a little bit. If you look at the map here, you notice that globally it's more humid around the equator because it's warmer. Warm air can actually hold more moisture than cooler air. So the farther you get toward the poles, the less moisture and the less humid that air is. Not everything in the atmosphere is in a gaseous state. They also get, guys, this is where it gets a little disgusting. You get tiny particles of dust. There's tiny particles of soil. There's tiny particles of fecal matter. Yes, that's fecal matter. That's your poop or animal poop. There are metals, there are salts, there's smoke, ash. There's all kinds of other solids that are also found in air. The particles, though, are so teeny tiny that you can't see those particles without a magnifying glass. Although I will say, if you have ever seen the sun streaming in a window and you see tiny particles floating around in the air, those are dust particles and other kinds of particles floating around in the air in your house. Without these particles, it's kind of important that we have them, because without them, water vapor wouldn't have the matter that it attaches to form raindrops and snow and things like that. So we need those particles in the air to gather the water vapor so that the water vapor can form liquid water, which enables life to be on our planet. We're going to talk about pressure and density. The elevation above sea level is called altitude. Sea level has an altitude of 0. Below sea level, so anything down in the ocean and things like that, have a negative sea level, or you could say that they are so many feet below sea level. Anything above sea level has a positive, or you would say that it's however far above sea level. So elevation above sea level is called altitude. The higher you go in altitude, the less air density there is. So air's density decreases as altitude increases. So what that means is that the air particles, because there's so much pressure, the farther you get closer to Earth or to sea level, the more pressure there is holding the air together, because gravity is strongest at sea level. So the farther you get from sea level, the less gravity there is, which means that those air particles that are being pushed together at sea level, as you get higher up, there's less gravity. So those particles are able to move apart, which means that the density decreases. The same applies to air pressure, the force of air weighing down on an area. That's what air pressure is, how much air is weighing down on an area. This is why when you go up into the mountains, or you go up in an airplane, you'll feel real pressure. Or if you swim to the bottom of a swimming pool, you'll feel a lot of pressure in your ears. And sometimes your ears will pop. Sometimes you force your ears to pop. You equalize the pressure in them. That's what popping means. Composition of the atmosphere stays the same with altitude, except for in one place, and that's in the ozone layer. So I want you to think for a minute before you go today, how would Earth be different without our atmosphere? You should be able to answer that question. You should be able to name at least 3 ways. that Earth would be different without our atmosphere. What are the components of the atmosphere, and why are those components important? If you have questions, please don't hesitate to email me. That's usually the best way to get a hold of me. Our Zoom meetings are going to be moved to, they're still going to be Monday and Wednesday, but I think it's 11 o'clock on Monday and 12 o'clock on Wednesday until we go back in person. Then that will change to second period because that's when my prep period is. But if you have questions, don't hesitate to email me. I usually get back to people pretty quickly. I hope you have a wonderful rest of the day. Bye.